Modified Linux format, basically.
It's like an ext3 or 4.
Something like that.
Right.
But it has Apple in front of it, or I in front of it.
Yeah, there you go.
IEXE4.
All right, so I got the exam mostly graded, except for about 3 people. Due to technical difficulties, I have to rescan, the test, and yours is one of those. But other than that, it's all graded. Yes.
I had a question. I was looking at it, and it looks like you only graded 2 questions on mine.
I finished the other 2 last night.
Okay.
Early this morning.
I haven't looked it up.
2 a.m. Whatever.
Put it up right now.
However you want to count it.
Attack.
Yep. Okay. Thank you. Yeah, because the scanner, for some reason, just
Right
kind of
here.
skip some pages, so I have to rescan it. Yep. Go ahead. Sorry.
Did the test have like extra credit opportunities on it or something?
This test does not have extra credit.
Okay, because I'm looking at it right now. I'm not too bad at class.
Okay.
You got 110%?
Yeah, I got some.
You got.
Hey, you just hush and
Okay, go ahead.
put your head down and
I don't know what you're talking
accept the
about.
extra credit.
Okay. Wait. Okay.
At the
Go.
beginning of the course, do we start off with 0 points and we just accumulate points
Yep.
as we go?
Yep. The second exam and the final exam are already on the grade book, so that's why your overall score is divided by the by the total, and that's why most of you are still in the quote unquote failing grade because we have not accumulated enough grades for that purpose. So yeah. But you have to look at each individual test to see how well you're doing in the class. Okay. I have to say that I was surprised. Most people did really well with the pre and post condition question. Yeah, I was pretty impressed. The last question turned out to be one of the trickier ones. I think a lot of people only get partial credit for the last one, the one where you have to find cases of values of x and value for y. That one turned out to be a little bit tricky. And you can definitely tell the difficulty increases as the value of z increases too, because you have to make sure that it has to be false for all the previous conditions and only true for the current condition, and that makes it a little bit difficult. Other than that, I think the overall score of the class is pretty good. Can you guys see your own ranking? Did I turn that on?
Yeah.
Okay, so that's a pretty good indicator too. If you have a good score already, don't be bothered that somebody else has a higher score. If you rank 2 in the class, I wouldn't worry too much about but I'm still lower. I have a lower score than that one person. I wouldn't worry about that too much.
Just means you need to go meet them up in the parking lot and settle it.
The only one?
Parking lot out of campus in that case. Yes.
Come on.
It's gotta be violence, but can you just ask for those?
So that we can involve
Yeah, there you go.
so that we can involve the sheriff
you
directly
ask
and
them,
not
just
the
go.
campus police.
Because it's usually against the law.
I never said you had to beat them up or anything. You just assume that.
That's why we're in school. Is to
School is supposed to be a safe, friendly place, I know, but
Exactly.
not the case.
Not the case.
not always.
All right, so you do have a new homework assignment, and I know it is time. We are way overdue for a new homework assignment. And this one is binary search, and we have already dealt with binary search in the past week or so. And this is basically really just a fortification to make sure that people understand what binary search is and how it works. This is the algorithm of binary search. We have talked about that a few times already. Are there any questions about the algorithm itself?
Can we run through it once here in class?
So I have E written down as the second line. Is E
Oh,
is the
E-
value of
yes, I forgot.
bar A bar minus 1.
No, you're right. I messed up here. E should be initialized to bar A bar minus 1 because it is the index of the last element. If it starts with 0, then I guess we'll not be finding the element in most cases. We'll only find 1 in these cases. We have sheet 2, 3, and 4 as test cases. And let me just double check on sheet 1 to make sure that I don't make any additional mistakes. If A bracket M is less than K, then B gets M plus 1. Else if K is less than A bracket M, E gets M minus 1. And if until a bracket m equals k or b is greater than e, and then this part is new too. Found is a variable, and it has a value of a bracket m equals k, so that we can indicate whether we actually found the item or not.
And that's a Boolean? So it's true
That's a
or false?
Boolean. Yep, it's true and false because a bracket m equals k is a Boolean expression. So what I'll do is I'm gonna save it, and I forgot where I save it to. So it's in downloads. Okay, I'll fix the assignment right now so that you will download the correct one. And after this topic today, we're going to start on subroutines. Okay, and subroutine is a very, very useful concept. How many people still remember the whole idea of top-down design? Okay, placeholders. Okay, we want to take a piece of algorithm out so that the overall algorithm is not as complex. So what we'll do is we'll finish up that topic and actually introduce a concept to implement that, which is called subroutines. So I'll just have to upload the file right now, get it done, and then we can move on and deal with the other stuff. And it's called binary search. Let's search by last modification time. And now it is fixed. All right. Okay. Are there any questions? That was a good catch. Any other questions about the binary search algorithm? Let's go over those test cases, one by one, and make sure that we know what to do. The first test case, they all have 4 elements, and it's the same values for the 4 elements. Except in this case, because we have 4 elements, there's no one single middle element anymore. So you have to understand how to use the floor function to pick one of the 2, quote-unquote middle elements. The 3 test cases really has one having 8, which is larger than all the values in the array. The second one has -3 as a search value, which is smaller than the smallest element in the array. And the last one is 7, which is the last element in the entire array. So I want you guys to use these test cases to figure out whether you know how to trace or track down the algorithm itself. And that's it. That's really not much to it. It's really just a trace. Any questions that we can talk about regarding the binary search algorithm or arrays at this point before we move on to subroutines? No questions about arrays? Okay. So we'll go ahead and start with subroutines. And I'm going to change the highlight to the next one, which starts up the discussion of subroutines. Okay. I have always have problems with this particular topic, not in terms of the technical content of what a subroutine is, what it does, and so on and so forth, but rather, how do I explain the necessity of a subroutine? Why do we need subroutines? But we actually have talked about the rationale of subroutines already. Okay, when we talked about top-down design, remember, how I kind of mentioned that each algorithm should really only have about 20 to 50 lines. Okay, definitely no more than 100 lines. But you cannot write Microsoft Word or some other complex software in just 100 lines. So how do we break up a program so that each piece is only 50 lines or so? It's really the same question of how do you how does a file system contain hundreds of thousands of files? How do you organize your files? Well, we already know the answer. We use folders. So that in each folder you only have a smaller number of files and subfolders. In a way, a subroutine is kind of like a subfolder. It can be used to structure your program, but it can also be used for many other purposes. Okay. This one is kind of hard to explain. So let me write this code first, and then you guys can tell me, how we can improve this program. So I'm going to use this as an introduction and also a rationale part of the discussion of subroutines. So we'll use mousepad. And let's just say that I want to write the code to ask an end user to enter two numbers. Okay? The first number has to go from 0 to 100. The second number has to go from the first number to 100. In other words, I'm trying to specify a sub-range within 0 to 100. Is that okay so far? But I also want to do error checking. In other words, if the end user gives me a number that is unreasonable out of that range, I want to use a loop to check that condition and then give an error message and then go back and ask the user to enter the number again. Is that okay? So let's go ahead and write a code. We really have enough tools to write this program already. And instead of evolving the algorithm step by step, I'll just give you the whole thing. Okay. So to read the first number, we'll start with repeat. And we'll say read, since this is the beginning of the entire range, I'll say read variable b from the command line interface or from the user interface. So this can be reading from a command line interface. It can be reading from a dialog box or something along that line. I really don't care at this point. I just need to know, okay, how do I read that number in? And then I can do some range checking. I can say if b is less than 0 or b is greater than 100, then I know this is out of range. So I'll just print an error message and say, b is out of range. Okay. I use double quote between is out of range, including that leading space, because I don't want to print b literally and say b is out of range. I want to say the value of b is out of range. So this will print the value of b and then append is out of range to the number that is in variable b. And if the until condition is pretty easy, I can get out of the loop when b is in range. In other words, when b is greater than or equal to 0 and b is less than or equal to 100, I can get out of the loop. Is that part okay? How do I read the end of the entire range? Something very similar, right? I can say, repeat, read E for the end of the range from the user interface. And then I can say if, now this time the comparison is a little bit different, because if E is less than B or E is greater than 100, then I want to print, E is out of range. Now I can improve the error message a little bit and say, what is the range? Okay. But let's just say that I don't want to go through that trouble and just do this part as specified here. The until condition is E has to be greater than or equal to B, and E also has to be less than or equal to 100. So do we have any questions about the algorithm itself, what it is trying to do, and how it's getting the job done?
Pretty simple.
Pretty simple, and it works. Okay.
Shouldn't you put like a prompt in to prompt the user to input something?
Yeah, we can prompt. Sure. Yep. Go ahead. Okay. So we'll make a prompt, and which is actually a pretty good thing too. So we say prompt, and we'll prompt the range. Okay. What is the range of the first number?
1 to 100.
Enter a number between 0 and 100, and we'll just say that it is implicitly known that it is inclusive. And then with the second number, it's a little bit more tricky because I have to say between b and 100, because b is determined by the first loop. It is no longer a constant. I can just say, okay, this is the constant. It's not a constant anymore for the start value of the second number. Are we doing okay so far with this? Mm-hmm. Do we see any similarities between the first part of the program and the second part of the program?
Yeah, it's very similar. All you did was replace 0 with b on the second part, and other than that, it's pretty much the same.
It's pretty much the same. Okay. So that means I could have just copied and pasted the first version and then just modify a few things and call it the second version, call it the second loop. What is the problem of copying and pasting and then modifying something?
You might miss a line.
Misalign. What do you mean by misalign?
Well, you might miss a line that needs to be modified.
Okay. Any other problems with copy and paste? Yep.
You might miss something when you make the modifications.
In my modification, I might have missed something. Very good. Can the compiler, remind me? Can an automated tool say that, hey, tag, you're supposed to change that number too?
Not if the syntax is correct.
Exactly. So the meaning of the program can be wrong in the copy, and the syntax can still be right, and there's no automated tool that can give me a warning and say, hey, this is wrong. That is the first problem. The second problem of copying and pasting is this is not a big deal, okay, because it's relatively short. What if I'm copying and pasting, let's say 100-line pseudocode 20 times?
Yeah.
Well, it's all over the place. My program gets blown up, quite a bit because now I have 20 copies of that 100 lines of code. What if later on, like years later, I found that the original 100 lines of code that I copied from, there's one bug in it, and I need to fix it.
Yeah,
What happens to the 20 clones that I made out of that faulty code?
You got to fix each one of them too.
I need to fix each and every single one. Do you think that I can remember where I pasted that 100 lines of code not 20 times all over the place? I can probably find a few, but I may not be able to find all 20. Right? What is the problem with that approach? The code becomes very unmaintainable. Everybody makes mistakes. Okay, that's not a problem. But if I have to if I make one single mistake, I replicate the code 20 times. Now I have 20 places to fix. If I miss one place, nothing or no tool will be able to tell me that, hey, you're supposed to make 20 fixes because you made 20 copies. No tool is going to help me to fix all 20 copies. Okay, are we seeing a few problems with the copy, paste, and modify approach? So what do you think would be a good solution? When you see something so similar, what would be a good approach? What do you want to do? Or what do you want to accomplish? So that we don't run into that problem that I just described. Go ahead.
And HTML, you create a CSS, so it makes modifications to the whole thing, not just...
Aha! Now that is a very good comparison. I've never thought of it that way. But it only applies to people who understand HTML and CSS already. How many people know vaguely what is cascading style sheet? Okay, quite a few. Very good. But what do we use CSS for?
Formatting.
Yeah.
Formatting.
Large websites that have a bunch of different pages. So you
Right.
keep them all at the same.
Templates, very good. Okay, so that means when you use CSS correctly, you can change the look of a page. How elements are formatted. The background color and stuff like that. You can change it all consistently with one little change to the definition of the cascading style sheet, to the style itself, right? So we want to do something similar in programming where we can quote unquote have a template and we just make one change to the template or we fix the template, then everything that refers to the template will also be fixed. We want a construct that kind of looks like or behave like a template. In programming, we have to be careful because there is a concept called template in C++, which is not what we are talking about here. What we are talking about here is called a subroutine, which is a way to abstract similar code into a single copy, and then you can specialize those different copies using a different mechanism. We'll talk about that mechanism later. So the first thing we want to do in order to generate quote unquote a template. Now in this class, when I refer to template, I would have to say quote unquote because it is not the actual programming template concept in C++. It is actually a word that I borrow, so that we can describe the concept at this point. Okay. So what we want to do is to first compare these two chunks of code and say, okay, how much of this is similar and what are the differences? We'll go ahead and identify the differences between these two code, and we'll just use a template here. And what the template does is whenever we see something that is different, we'll use a question mark to indicate, hey, this thing is different between the two versions of the code, and we need some special consideration there. One thing that's definitely common is that both post checking loops, right? That part is pretty common. We also know that they both start with a prompt of something, and the prompt is very similar for the most part. It says, enter a number between, okay? But this part is different because one specifies a constant of 0 and the other one specifies the value of variable b. So I'll just use a question mark here to say that, well, this part is different depending on which version of the code we are talking about. Okay. What about the 100? Well, that part is the same in this case, but do you think maybe later on I might want to change that to where the range ends? It's easy enough, so we'll just use 100 for now, okay? And then we'll say that later on we'll also take care of that one. Okay, what are we reading into from the user interface? Not a particular variable. It's not common to the two chunks of program. So we'll say read question mark from the user interface, and then later on when we do the range checking, well, the variable itself is it depends on which chunk of code, and the beginning of the range also depends on which chunk of the code we are talking about. So we can only do certain parts of this at this point. So print question mark is out of range, and if, and the until is also kind of the same, because the variable that we are trying to read into is different, and also the start of the range is also different depending on which part of the program we are talking about. All right, so now we have a template like this. Are we doing okay so far with the template? Okay. So looking at the template, we'll say, we'll go ahead and use a third variable for for B and E, and also use a third variable for the beginning part of the range. Okay, so we'll say the beginning of the range here is we'll say start here. Okay, we'll use a new variable for that purpose, a third variable that we have not used in both of the programs. And the variable that we are reading into, I'll just generalize that to V. And now we can say if V is greater than start, or V is greater than 100. Oops, wait, hold on a second. Got it flipped. If the value we are reading in is less than the start of the range, or the value that we just read is greater than 100, we have to print the message and say the variable is out of range. And to specify the exit condition, we have to make sure that V is greater than or equal to start, and V is less than or equal to 100. Do we kind of see what is going on here? In the original code, in one version I have B and 0. In the other version I have, B and 0. In the other one I have E and B. So I don't want to refer to E or B in this template code, because then it will only work with one version of the code. And that's why I come up with a new variable called start to represent the beginning of the entire range. And I also come up with a new variable called V to represent the variable that I'm trying to read into. Are we doing okay so far? Yep.
Don't we need to define start?
Define start? Yeah, we need to define start, but as far as the logic of the program is concerned, this captures the common logic between the two chunks of code that we are trying to create a template for. Are we doing okay so far with the template? So with this template, okay, so we can call this template, we'll call this template read with bound checking. Okay, which seems to describe what it is doing. Okay, so So with this chunk of code, the original program can now be rewritten as follows. Okay. The first chunk of code, we can replace it with a reference to the template. But before we refer to the template, we have to do certain things first, because we have to specify what is start. Okay. So before we get started here, we'll say start as a variable. It's just what should it be for the first chunk of code at the top of the screen right now?
0.
0. Very good. Okay, and then the next thing we'll do is to say, okay, in quotations, because we'll replace that with the proper terms later on, do whatever template read with bound checking specifies. Okay, does that make sense? Okay, but after it is done, I have one additional thing to do, because the template is only reading the value into a variable called v, not variable b. So what should I do about that particular situation? How do I get that value into b?
B gets a value of V.
B gets the value of v. Okay, simple enough. All right. So how do we deal with the second one? First of all, yep.
How in the program that you wrote there does whatever value is entered go into V? Is that just automatic, or how does that work out? So using the template, the original program where it's default start with or start gets a value of 0. Where in there does it tell the entered number to get V to get the entered value of the number the user enters?
How does v get the value?
That the user enters in.
Just this statement here, read v from the user interface. That part really depends on the programming language. In Perl, you just read it from standard in. In C and C++, you have cin. You can also use scanf. And then in Visual Basic, you can actually pop up a dialog box to ask a user to enter a number, and then press Enter key to continue. So it depends on the programming language, and that's why I just use a kind of vague but general description of okay, whatever you do, just read a number and put it into the variable called v in this case. Yep, go ahead.
Is that a B at the bottom?
At the bottom, yes, that's a v. The screen is not aligned correctly. Let me see if I can fix that. Some of these have better user control than others. No.
That's fail right there.
It's not moving it, that's the problem.
Somebody just needs to get up on a chair and...
Is it actually displaying? Oh, it's just the screen being off a little bit. Okay, let me see if I can get that fixed. Projector setup. Position.
Second one from the top. There you go.
Shift. There.
Yeah, but then we lose the other end.
We don't need the bar.
It's just a bar.
That's only for you to see.
Good enough.
It's alright, it'll still show up on the YouTube video.
Yeah, it will. Okay, I think we can just let it time out. Nope, does not time out.
Push return.
Push return. Okay. There we go. Good job. Okay, so are we doing okay with the first 3 lines? So the second 3 lines will be, well, first of all, we have to change start, because with the second number that we're reading in, the beginning of that range is going to be the value of the first variable, b in this case. So we have to make sure that we update start before we do the same thing here. Oh, we will just go ahead and do whatever the template read with bound checking specifies. And when it is all done, when the template is done, we're back to this point, then this time we'll use v to update variable e, and we're done. Are we doing okay so far? Let's say I made a mistake earlier, and let's just say that I made a mistake like this. Instead of using greater than or equal to get out of the loop here, I use greater than. Okay, obviously the program is not going to behave the way it is supposed to, but in this case, to fix this entire program, I only need to make the fix once. I only have one place to fix the program, and in both places where they refer to the template, the reference, there's nothing to fix with the reference itself. I only have to fix whatever it is referring to. Are we doing okay so far with the concept? It also helps to make the program smaller, because now in terms of representing the logic of the program, I only have one copy of this logic. Instead of in the original program, I have two copies of that logic. But there's one added benefit, which is kind of intentional. It really should be intentional, but some people will say, well, maybe it's unintentional. The added advantage is the program gets easier to understand, because these 3 lines is replacing, all the details of the logic that we have expressed earlier. And then these 3 lines, refer to, or they will do the same thing as, these 7 lines of the original program. Yep.
I thought the idea, because down at the bottom you have it in there twice. I thought the idea was to replace it so it's not redundant like it is on top. When you have copied it and make a copy of each other. That was the idea of the template. Was to only have those 3 lines instead of 6.
Well, you still need 6 lines because I still need to change or re-specify the start of the entire range. And I still need to specify, where do I store the value. So at this point, we don't have the necessary tools to combine each line in each. Okay, when we are all done with subroutines, with parameters and stuff like that, these 3 lines can be combined into a single line. And then these 3 lines can be replaced by a single line. We just don't have the ability to do that yet. Okay, so the concept of a parameter is necessary in order to do that. But I don't want to introduce parameters, local variables, and all that stuff all at the same time. So right now the focus is really just defining a template like this and be able to refer to the template and just say, do whatever the template specifies, and then come back and continue with the rest of the program. Okay.
So why do you update B with B after the template?
You mean here?
Yes.
Because in the original program, I'm reading the number into B first. After this code, some other code would use B and E for some other, purposes. I don't know what it is, but whatever I write to replace the original code needs to have the same effect as the original code, and this will have exactly the same effect as the original code. That's a good question. So are we doing okay with this example at this point? Mostly, the rationale of the template. Okay, that's the most important part. Is why do we want to use templates?
So,
go ahead.
Is this basically what they do with object-oriented
Not
programming languages?
quite. In this class, we don't really have enough time to get into object-oriented programming. Object-oriented programming is changing the way you look at things, but even in object-oriented programming, you still have subroutines or quote-unquote templates so that you can combine instances where you need a particular piece of logic, and you can make it so that it's generalized, and then you can refer to the same template over and over again. Okay? But this part has nothing that is related to object-oriented programming yet. All right. So now that we have, now that we understand the concept, then we have to change the terminology just a little bit. Okay. To change the terminology, what we'll do is I'll just go ahead and copy and paste this program, and I'll use a little marker here to indicate this is the new version. So what I do is, instead of calling this template, I will call this a subroutine. Okay. In other words, what we called a template in the past 35 minutes or so is now called a subroutine. So we'll say define subroutine, and instead of just spelling out subroutine, I just call sub here. And just like everything else that we do in this class, if there's a begin, we'll have an end. Okay, so define and we'll say and define sub here. Just like if has an end if, while has an end while, define sub has an end define sub. You need to mark where the definition of the subroutine is ending. Okay. And this part here, read with bound checking, becomes the name of the subroutine. This is how we can distinguish all the different subroutines and say that, oh, I want to refer to this subroutine and not the other subroutine. The rest of it we can keep exactly the same way it is, as it is. Just like that. Yep.
When defining a subroutine, it doesn't mean in parentheses or quotes or something to distinguish that it's a subroutine or title of a subroutine.
No. In this class, in pseudocode, we just have this use, define sub to know that we are defining a subroutine. That's remember it's only pseudocode, so it's the syntax is not important. Whether you want to use define sub colon, it's the same to me. It doesn't make any difference in that case. Now we also have to make some changes to the original program. This part here in double quotes, do whatever template read with bound checking specifies, is now going to be replaced by in this class a specific term, and I use the word invoke to specify that we are going to use the code specified by read with bound checking, and we'll do the same thing here. And by the way, no programming language actually use the word invoke. Some programming languages use the word call to say that we are going to the template and going to the subroutine to execute whatever is there. But in this class, I just call it invoke because call is a very common word and sometimes it can cause confusion. Invoke being a really obscure word, I can narrowly define its definition in the context of this class. Yep.
Subroutines like modules.
Subroutines are not modules. Are you referring to Visual Basic modules or Perl modules and stuff like that?
Yeah.
A module can contain subroutines. In other words, a module can contain variables and subroutines and a few other things. But a subroutine can only be a component of a module, but not a module itself. It does lend itself to modular design, but by itself it is not a module. All right, so we have already introduced all the terms that is needed in this class, and this program is now conforming to the standard of the pseudocode for this class to express the concept of subroutines. Yep.
Why do you not capitalize the first letter of the name of the subroutine? I noticed you do that when you're naming your files.
It is a naming convention. There's probably a good reason for that, but in programming, what people do is, except for a concept that we haven't talked about, the type concept, all the names, would use a lowercase to begin, lowercase letter to start. But if you want to use multiple words within the name, then you use the uppercase to separate the words from each other. It's more a convention than anything else. Most programming languages would not mind if you use uppercase R here. It's just that by convention, we do not do that. It's more or less the same as in sentences. Okay, we start a new sentence with an uppercase letter, and there's no particular reason why we do that except for the readability of sentences. It's kind of the same thing here. It's really just a convention of programmers.
Would that be so that it's easier to autocomplete when you're searching for a file?
When you're searching for a file.
With Bash, you can autocomplete. So you type the first letter and hit tab, and it'll start filling it out for you. And that way you don't have to capitalize the first letter, and it'll start.
It might help a little bit with autocomplete, but it's not really that much of a saving. Whether you press the shift key or not, it's not, doesn't matter all that much. Because in C programming, I can give you, counter examples of that. Because we use the curly brace a lot to indicate the beginning and the ending of stuff.
Yeah.
And the curly brace itself requires a shift, key also. So it's not really for the typing efficiency, it's really just a convention more than anything else. But it's a convention that is used not only by C programmers, but also by programmers of all other programming languages now. So when you read a program written in PHP, Perl, C for sure, Java, and so on, they all conform to this standard. Okay. Any questions about the program? Yep.
So is the first part the template and the second part is the actual program?
Yes. The first part is really a template, which by itself doesn't do anything. It's more or less like a word definition in a dictionary. And the second part, where you say invoke, is a reference to that word. In other words, invoke is looking up the meaning of read with bound checking, and then perform the operations that is defined in the subroutine called read with bound checking. You had a question? Yep, go ahead.
If you use the word invoke, could you just as well as use execute? Or is that something different?
In the world of programming, execute has a different meaning, because execute typically applies to a program. You execute a program, but you do not execute a subroutine. So if I use the word execute, that would kind of imply that read with bound checking is a program instead of a subroutine. So that's why I have to use the word invoke instead of execute.
Typically, would you keep your subroutines in a different file from your main file? That way it would keep the program shorter, or would you do it just like you did here?
In this class, we only have single file programs, so all the subroutines and the main program will be in the same file. In smaller programs, that's really typically the case. When you have programs only up to maybe 300 or 500 lines, most people would just keep all the subroutine definitions within the same file, so that it's easier to look up, okay, but what is the definition of the subroutine? When you get into the C class, you will realize that everything in C is a subroutine. There's no such thing as the program itself, because the quote-unquote program itself is also a subroutine, except that subroutine is invoked implicitly by the system.
Okay.
Yep. So in that case, you can actually have one subroutine definition per file. The problem with only having one subroutine per file is you have to open up many, many different editors to see how your program is actually written. So the organization is good in that case, but it's also making things very tedious when you need to look up.
You start needing multiple monitors at that point.
Or you just use smaller, text boxes, like I usually do. Any other questions about this particular program? Just the meaning. At this point, we are not too concerned about how it is done. We just want to understand the meaning of a subroutine. And we also want to distinguish the definition of a subroutine, which describes what it does, and the invocation of a subroutine, which is basically saying, okay, we want to do whatever the definition is specifying. Is that okay? Okay. So in the next one, you will go ahead and trace a program that has subroutines. So to do that, we'll use our usual stuff. Use our spreadsheet here, and we'll define a very simple subroutine here. I'll just call the subroutine X, and subroutine X doesn't do much. All it does is to say, okay, I guess I plus 1, and define sub. So it doesn't really do anything that we don't quite know already. And outside of the subroutine, in quote-unquote the main part of the program, we'll do something like initialize I to 0. We'll go ahead and invoke subroutine X, and then we'll go, let's say I gets I plus 10. Okay, we'll go ahead and invoke X again here, and then we'll say I gets I times 2. Okay, this is my program. It's not it's not complicated at all. It only has 2 references to the subroutine X. But it will describe the mechanism of how to invoke a subroutine, and particularly, what do we do when we're at the end of a subroutine? How do we know where to go back to? Okay. So we'll go ahead and trace this program with our second window. resize it. Resize. Here we go. And we'll try it without a particular concept that we need in this class, and we'll see the limitations first, and then we'll go back and say, okay, so I guess we need something to fix that problem. In this program, we have variable I, and we'll just keep track of the line number, just like usual. Nothing major. Okay. The first thing we understand when we have a subroutine is we don't start execution from line 1 anymore. Because line 1 is really just the definition of a subroutine, but you don't do what the subroutine specifies unless it is invoked. And the invocation doesn't come until much later. So what do you think would be the first line that we execute in this program? Line 4, because line 4 is outside of the definition of a subroutine. The first line that is outside of the definition of a subroutine is line 4 in this case. Very good. So we start with line 4. Line 4 initializes I to 0. That's pretty easy stuff that we can do. And then we move on to line 5. Line 5 is going to invoke X. So what do you think is the next line that we are going to execute? Remember that certain lines are not useful. They don't really do anything useful, and we don't trace those lines. So where should we go at this point?
2.
We go to line 2. Very good. And what does line 2 do to I? It increments it. We know how that works. So I goes from 0 to 1. Now where do we go?
6.
We go to line 6. Now that is very good, but how did you know that we have to go to line 6?
The first one after the subroutine is invoked.
Okay, all right, so I will take that. But I'll also put a little note here and say, how do we know to continue on line 6? That's a question, because in the trace here, nothing specifies that we should go back to line 6. Okay, but it doesn't matter. We'll continue. We move on to line 7. Line 7 itself doesn't really do much. So where do we go from line 7? We go to line 2. Yep.
You have to make line to 11 on line 6 or no?
So again?
You didn't do what you're supposed to.
Oh, okay.
Decided +1.
Oh, okay, I see. So line 6, it will add 10 to 1 and makes it 11. Okay, very good. Then we continue on to line 7. And then from line 7, where do we go?
2.
We go to line 2 because we are going to continue execution in the subroutine. And then from line 2, on line 2 we add 1 to I again. I goes from 11 to 12. And then where do we go?
8.
Now how do you know we go to line 8 here? Nowhere in the trace does it say anything about continuing on line 8. Now we'll finish line 8 first. Line 8 is going to multiply I by 2 from 12 to 24, store it back into I, and there's nothing after that post. But the two lines that bothers me is line 6 and, row 6 of the trace as well as row 8 of the trace. Particularly, how do we go from line 2 to line 6? How do we go from line 2 to line 8? That bothers me. Okay? How do you know where you're supposed to go back to? Subroutines are kind of like a boomerang, okay? Wherever you launch the boomerang, it will come back to the same point. How does it know? Yep.
The line before it.
The line before that.
On line 7.
On line 7. So line 7 does the invocation, and therefore it should go back to that line. Okay? Yep, go ahead.
You have to trace line 5 and line 7.
Line
Because
5.
It doesn't really do anything except indicates it's kind of like a marker.
Line 5 and line 7. Okay, very good. Now just kind of imagine that you're lost in a forest, in the woods. Okay, you guys have heard that childhood stories many times already. How do you keep track of where you have been to already? Breadcrumbs. That's basically just feeds the squirrels. You're bribing the squirrels, hoping that they will tell you, where to go next, right? Okay, so what we need here is something similar. Okay, when we go into a subroutine, we have to leave something behind to remind ourselves and say, when this subroutine is all done, this tells me where to go to continue execution. That's what we need. Because what we want is, I know this seems obvious to you. Okay, you look at this code, you look at the trace, and then you understand the concept of a subroutine already. So it seems it is very clear to you what we are supposed to do after line 2 in both cases. But when you have a program that is complicated and the difference or you have like 20,000 rows between the invocation and the end of the execution of that subroutine, how do you know where to go back to? It's very difficult, okay? So unless you have a very systematic way of remembering in the invocation, you remember where to go back to, it becomes really hard for you later on to say that, oh, I'm at the end of this subroutine, where do I go back to? So this works, but it doesn't quite explain how it is done. So what we'll do is we'll use another sheet to demonstrate. Maybe we can do a little bit better and make it very explicit and remember where we're supposed to go back to. So in this case, we have the same variable I, which is also unknown when we start as the precondition. So this part is not changed. It is the same as the program before, or the trace before. We start on line 4, same thing as before. It initializes I to 0. We move on to line 5. But this time, when we execute line 5, it is no longer just saying continue execution in subroutine X. We actually go ahead and allocate a column on the fly, like on demand, and then say, I'm going to use this column to remember where I'm supposed to go back to. Okay? Where I'm supposed to go back to when subroutine X is done. Okay? And I'll just label this as return line number, because that's exactly what it is supposed to do, is to remember where do we return to when the subroutine is done. And this also introduces a new term called return. At the end of a subroutine, that's when we have to use it's an implicit return to go back to wherever we're supposed to go. Okay, what should I write down here? Which line should I return to when subroutine X is done, when the invocation is on line 5? Line 6. Okay, we don't want to write down line 5 because if the return line number is line 5, then we're going back to line 5 and we invoke X again, and then go back to line 5 again, and then we invoke X again, so that will never end. And that's why the return line number, at least at this point of the class, is the line following the invocation. Are we doing okay so far with the return line number concept? That's our breadcrumb, okay? Except squirrels cannot eat a return line number. Yep.
Why is the return line number much lower, and why is it at the very top of the
because it is allocated on the fly. You will see later on. This is where we start to allocate columns on the fly and deallocate columns on the fly too. In other words, in this case, column C is only in use when we have a label. And we will also use a particular way to indicate, oh, this column is no longer in use anymore. It is available again when we need to use it again. Okay. Very good question. So once we set this up, we will continue execution in the subroutine. Now what this means is the execution of a subroutine or the execution of the invoke statement now has 2 steps. The first step is to allocate a new column, label it return line number, write down which line we're supposed to continue on when the subroutine is done, and then the second thing is to continue execution in the subroutine itself. Are we doing okay so far with those 2 particular actions when we invoke a subroutine? Don't do anything else. Remember where you're supposed to go back to, and then go to the subroutine and continue execution in the subroutine. Yep.
So if I understand it correctly, when we execute line 5 versus invoke X, it goes to line 2. There is a marker in memory that tells it to return back to line go to line 6.
When the subroutine is done, yes.
So line 5 acts as an anchor. When the return is executed, it goes to the next line.
line 5 is not really an anchor. Line 5 is just saying, invoke X, but it triggers 2 actions to happen. The first action, when you execute line 5, the first action is to remember where you're supposed to go back to, and then the second action is continuing execution in the subroutine. All right, so now we are on to line 2. Line 2 does the usual stuff that we already know, which is incrementing I by 1. I goes from 0 to 1, and now we trace line 3. But Tech, didn't you say that lines that are not doing anything useful, we don't trace? Well, guess what? Line 3 actually does something useful in this case. Because end defined sub means at the end of a subroutine, we have something special to do because we are changing the flow of execution again. In other words, we are not just going to continue execution onto line 4. At the end of a subroutine, we have to look up the return line number and say, oh, I know that I wrote down where I'm supposed to go back to when I executed the invoke statement. Now it is time to look it up and so that I can continue execution where it is indicated. Are we doing okay so far with that? So that's the first thing you do at the end of a subroutine is to look up the return line number and then say, oh, the next line to execute is line 6. And then what you do is also something that we have not done up to this point of the class is we now deallocate this column. In other words, we indicate that this column is no longer in use. And the way I do it in the class is to use a strike through font style to indicate that this column is no longer in use. If I want to keep track of when a column is actually in use using the background color of a cell, this is when the column is actually in use. Okay? The yellow highlight specifies when column C is actually in use. Yep.
Why do you have all these different formats if you say traces aren't even real in the real world?
They're not. Well, that's a very good question. Since I also teach the assembly programming class, the traces are closely resembling how memory is used in a real program, executing a real program, particularly C programs too. So what we are doing here to explicitly remembering where we return to, where to go back to, this is actually in a real program, in a real computer, this is actually using some memory locations for the same purpose. It doesn't really use line numbers and stuff like that, but for the purpose of this class, this is the best, the easiest way to represent, where do we go back to? Okay? In other words, if you plan to take CISP 310 here next spring, okay, spring 2013, all this stuff is going to come back, and you will see the same concepts all over again. Except in that class, we are not going to refer to these things as columns anymore. We'll be referring to these things as memory locations. So there's a very close resemblance between what we talk about in this class with the traces, with the actual happening, what is actually happening inside the computer in memory when you execute a program. Yep.
You struck out the return line the second time, but are we still using it because the trace 7 is telling us to go back to the
We'll use it. We'll reuse it. Okay. We encourage recycling and reuse in this class. Okay, we're back to line 6. Because the return line number tells us to go back to line 6, what do we do on line 6? Well, that's easy stuff. We're adding 10 to I. I goes from 1 to 11. Then we go to line 7. What do we do on line 7? What are the 2 things that we have to do when we invoke a subroutine?
We need to remind us to go to.
Define our
Oh yeah, we need to remind us to go to line 8 after we're done with.
Correct. So we'll allocate a new column. Is column C in use at this point?
No.
Nope. We can reuse it. So we can now reuse column C to remember that this time we have to go back to line 8, not 6 anymore. And then we'll continue execution on line 2. Are we doing okay so far with these changes to the spreadsheet. We're going to reuse the same column. Okay, now that we are on to line 2, we will add 1 to I. I goes from 11 to 12. Then we go back to line 3. Line 3, which is the end of a subroutine, we have to perform what we call returning from a subroutine. The returning from a subroutine will do 2 things. One is to look up the return line number. It tells me we have to go back to line 8. Okay, we'll write a note about that. But after we make use of this fact, then this column is no longer useful. So we'll use the strike through font to represent the return line number, or column C in this case, is once again deallocated. It is no longer in use at this point. So if I want to highlight the lifespan of this column, or when it is actually being in use, it's during, it's from row 9 to row 12. Now we're back on line 8. Line 8 is going to double the value of I. I goes from 12 to 24, and we're done. Are we doing okay with this trace? We doing okay with this trace? Okay. So let's go ahead and save this one, because this is actually kind of important. And we'll call this, simple subroutine invocation. Let's go ahead and make a slightly more complicated example. It's still the same concept. We're still doing the same thing, except this one is just a little bit more complex. Define sub x, I gets I plus 1, just like the previous one. And define sub y. And in subroutine y, we invoke x. And define sub. In the main program, we'll do 2 things. Well, first of all, we have to initialize I to 0, otherwise, we don't know what I is when we increment it. And what we'll do is we'll say invoke x here, and then we'll invoke y here. And then we'll see whether we know what to do with this program. Okay. So we'll fix the indentation.
Back into itself and then
to itself?
I don't like the way that you're invoking y to invoke x. It seems messier that way.
Well, the program really doesn't do anything useful. Its only purpose is to illustrate what to do when you invoke a subroutine inside the subroutine.
Yeah.
Yep, that's the only purpose of this program. It doesn't really do anything particularly useful.
It's just
size. All right. So we'll take a look at this program. Now remember, we really are not going to change how we do things. We have to specify some additional things that we have to. We still do the same thing as we always do. It's just that I have to specify a little bit more details this time. All right. So we have line number. We have variable I. Well, this part is kind of interesting too. Don't you realize that I starts existing from the very beginning of the program, and it only ends when we get to post? Okay, so kind of keep that in mind. We don't really need to know or understand that part at this point, but it doesn't behave the same way as the return line number, because the return line number comes and goes. It gets allocated and it gets deallocated. I doesn't get allocated nor deallocated. It's always there. Okay. Where do we start in this program? Which line should we start with? Line 7, because line 7 is the first line that is outside of the definition of subroutines. And then we go to line 8. Line 8 is easy schneezy. We know that already because the previous program have exactly the same thing. So we allocate a column called return line number. We remember that we have to go to the line following line 8. And that's the first part, or the first action of an invocation. Then we continue execution in the subroutine on line 2. We increment I from 0 to 1. We get to line 3. Line 3 is called the returning part of the subroutine. We look up the return line number. It's going back to line 9. We write down line 9 here. and then we can say that, oh, okay, this return line number column is no longer in use, and we'll just mark it as unused at this point or deallocated at this point, and we are done. We're now on to line 9. Okay. Any questions about this part from this row to this row? Same stuff as last time, right? Absolutely no real change from the last time. Line 9 is pretty easy too, because line 9 is invoke y. So we do exactly the same thing. We immediately reallocate column C for the return line number, except this time the return line number is post, because there's no line after line 9. So this will remind me when we get back from the subroutine, it's time to exit the program. We are all done. Okay, so other than that, we are really doing the same thing, except in here, we are invoking subroutine y, so we continue execution on line 5, right? Nothing mysterious up to this point. But what does line 5 do? It invokes x. Well, now we know that we have to do exactly the same thing. Can we use column C at this point for this return line number? We cannot, because column C is now allocated already. It is in use. So what we do in this class and also in the assembly class is we'll allocate the we'll allocate the leftmost column that is currently unused. What is the leftmost column that is currently unused?
D.
Column D. Very good. So we'll now use column D as a return line number. And where are we supposed to go back to now that the invoke is on line 5? Go back to line 6. Very good. Okay, no big deal here. And then we continue execution in subroutine X, which is on line 2. Are there any questions regarding this part of the trace?
Why did you word it that way, the leftmost?
Because I don't want people to allocate column E or column F and just some random column that is not used, because it has to be packed. We're trying to make columns contiguous. The use of columns has to be contiguous. Yep.
Shouldn't we define the return line in column D with a different name or something?
Nope.
No?
Nope, it's the same. A return line number is a return line number. We don't really need to know whose return line number, because the whose part is implied by what lines are we executing. If we're executing line 2 and line 3, we're in X. If we're executing line 5 and line 6, we're in Y.
Right, but once we've executed line 2 and we go to line 3 for the return line function, which column does it know to use?
We'll deal with that when we get to that point. So we're on line 2 right now. So you're just a little bit ahead of the discussion. We're on line 2. Line 2 does the usual thing. It adds 1 to I goes from 1 to 2. No big deal. Now we get to line 3. Line 3 now has a question and say, well, now we have 2 return line numbers. Which one am I supposed to use to go back to where I came from? Well, the general rule in this case is you use the rightmost return line number column. Okay? The rightmost return line number column in this case is column D, and it tells me to continue execution on line 6. Is that part okay?
Yeah.
But we also have to remember, once we use the column, once we utilize the return line number to actually continue execution, you have to deallocate it. So I'll be a little bit lazy here and just copy and paste the one with a strike through. Okay. Now we're on line 6. What does line 6 do?
That's C column.
Okay, it's also the end of a subroutine, so we'll do exactly the same thing. We look up the rightmost return line number. But the rightmost return line number is not column D anymore, because that column is no longer being in use. So the rightmost return line number column is actually column C, which tells me we have to continue execution at post. So we write post here, and then we also indicate that this column is no longer in use, and we're done. Yep.
So if you define y like invoke s, right? So y means exactly same thing with s. So why don't we just cross out Cost.
Because I want to illustrate how do you invoke a subroutine from inside the subroutine.
Okay.
Particularly when you return, how does it work? How does it know where to go back to? So this is how it works. So in this class, starting from this point, you will see the allocation of columns going this way, but when we are done with subroutines, it will go back in the opposite direction. How do you call this order of doing things?
Linear.
It's linear, but there's also a particular way to refer to this. It has to do with the ordering of what comes in and how do you relate the ordering of things coming in and things going out.
First in, first out.
This is not first in, first out. This is first in and it was last out. So this is first in, last out, or last in, first out. LIFO, L-I-F-O. Okay? First in, first out, and last in, first out are the two most common ways of organizing things in computer science. FIFO, at first in, first out, is useful for buffering. Okay? When you watch Netflix, through your Internet Explorer, it is buffering all the frames. But the buffering is done in a first in, first out fashion. Okay? The frame that you receive first will be played first. The frame that you received last will be played last. What happens when the buffering is using last in, first out when you watch Netflix? Exactly. You'll be watching a movie in reverse in blurbs because your buffering goes in like bursts. So first in, first out has its own application, but last in, first out also has its application. It is for purposes of this. In real life, what kind of devices or what is last in, first out in real life?
Procrastination.
So you only deal with the most recently assigned homework assignment, and then you work way back to the older ones. How about your refrigerator?
It's spatial.
As much as we don't want our refrigerator to be last in, first out, that's how things are, right? Because the first thing that you buy with an empty refrigerator, you push it all the way to the back. As you buy new stuff, you keep pushing, old stuff to the back of the refrigerator. But when you're hungry and you open your fridge, do you dig all the stuff, out, from the back of the refrigerator first? Most people don't. Yep.
I work at Target and they just put in all the fresh food in, so when we're stocking food, they make us pull all the stuff from the back and push it forward and they call it first in, first out.
Yep. Well, it is best if it is first in, first out, but it requires extra effort because of the design of a refrigerator. The only way to get around that problem is to have a carousel inside the refrigerator, so you can turn it like that.
No, you just need to have a front door and a back door on a fridge.
Front door or back door would work too. Yes.
That's how they do milk cases. Milk cases, they push the milk forward.
Yeah.
To the back.
Yeah. But if you think a refrigerator is bad, think of those freezers.
No, the chest freezers are the
Yeah.
worst because
Yep.
everything's on the bottom and then there's
Yep.
a frozen block of ice on the bottom.
But they don't grow mold either when they're in the freezer. Okay, what else is last in, first out in daily life?
A vending machine, when you load a vending machine.
Loading? Well, vending machines are different because when you open it up, it's actually loaded from the back to you. Yeah, so the new stuff. So the first thing that comes out is actually the oldest stuff too. Yep. How about U-Haul trucks when you move? Okay, the very last bicycle that you push in and then slam the door closed so that it won't fall out is the first thing that falls out of the truck. Okay.
Or it's the thing that gets the door stuck so you can't get it open. Or
Yeah.
it's the thing that gets the door stuck so you can't get it open.
You just have to park it, in a slight incline like that.
That's good. So it's
I almost got run over by a really heavy file cabinet when I helped my brother move. I was rolling it out of the U-Haul truck, using the ramp, and I was dumb enough to try to let it slide down when I. Yeah, that was not very smart.
Would you call it spatial?
Spatial?
Yeah.
What do you mean by spatial?
Like when you're packing things in, you have to fill that space first, and then you can get stuff out in the reverse order.
I've never heard of it being referred to as spatial. So what I want to do now, we have about 3 minutes left. I know some of you have classes after this, so I will not make this class any longer than it has to. Let me save this one first. This one is just calling a subroutine inside a subroutine. Okay, so say you invoke in a sub, not a submarine, but a subroutine. Okay, the next one, this is what I want you to think about. I know we are running out of time, but this is what I want you to think about. Define sub x again, but this time we'll say if I is less than 3, then I gets I plus 1. I gets I plus 1 invoke x, and if and define sub, and then outside I will say I gets well, let's make it start with 0 here, invoke x. Let me fix the indentation, because I really want you guys to think about this. We'll talk about it on Thursday, but this is an interesting one, don't you think?
Yeah.
This is called recursion. Okay, recursion, recursion, recursion. Okay, we have 1 minute and a half, just enough time to get this started. We'll finish it on Thursday. So when you look at this program, it looks, it's not really that complicated, is it? It only uses the concept that we have already talked about in the class. We have talked about conditional statements. It has an if inside. We talked about subroutines. It has define sub and invoke. But what makes this program tricky is it is invoking the very same subroutine that the invoke statement is in. Because if you look at, when you look at line 4 invokes subroutine x, but it is also inside subroutine x. Okay? So how does this work? Sorry? Will it be what? No, it is not endless, because each time before I invoke x, I increment I. So I start with a value of 0. Yes, it will invoke x, but then it will become 1 before I invoke again.
It just makes it a loop.
2.
It's just a dirty way of making a loop.
It is both called a clean and elegant way of making a loop. It's also called a dirty way of making a loop. It depends on your perspective. However, when you look at the trace perspective, what do you think the trace of this program will look like when you execute it, when you trace it? Okay, so this is kind of like your brain teaser for the day. Okay, we'll talk about it on Thursday. The trick to get this done is don't change the way of doing things at all. There's no special consideration whatsoever when you're tracing this program compared to what we have just done in today's class. So that is the trick. We'll talk about it on Thursday. Now you can brag to all your friends and say, I know recursion.
Isn't that just a dash R? Isn't that just a dash R?
Dash R?
It's the most common way of invoking a recursion.
Yep.
I have a major question about my exam.
Yes.
Okay. There is no way I can 20% on the exam. No way.
Okay. Well, there's a breakup of the points too.
Yeah.
So do you know which question you have a question about?
The whole thing.
The whole thing?
Yeah.
Like, okay.
Why is this exam 20%?
20%. Okay, the first one.
I got 5 out of 16 on this apparently.
Okay. Okay, with this one, you have to track down the inner loop. So you go from line 1 to line 2, line 2 to line 3, 3, 4, 3, 4, 3, 4. That part is right. But then when you go back to line 2 again, okay, go to line 6. Okay, this is where things start to go wrong. When you get into line 4, get back to line 3, and then go to line 6, line 2, line 3, line 6, that is right. Okay, well,
How would I get 5 out of 16 on it then?
I do not know. Look, yeah. Can you send an email to me and remind me to regrade yours?
Want to keep the original copy just in case? Like maybe
I have it
you have
scanned
a
already.
scan. Maybe it's like you scan someone else and then save it in my file.
That is
That's what I'm thinking.
possible.
Because so would you like to keep the original and I'll send you an email?
Okay, that's fine. Yep, send me an email. Yep. Okay.
I'm so glad I have a good teacher.
Well, since everything is scanned, I can just
And make sure you don't lose it.
Yeah, I won't lose it.
So,
Okay.
Okay.
I don't know how, but I somehow got 104.72% on the test. So, a little bit confusing.
Okay. I think it has to do with the number of points.
Yeah, somehow this one ended up at like.
Oh, I can send an email right now.
5.56.
I'll send it in the library.
Okay,
I want to
thanks.
bring my test in too because I want to see. I had a different version than the one that we went over in class. So I probably want to just review that one. the last
Okay, but the
question.
percentage is also off
Mhm.
for these ones.
Yeah, these ones it seemed fine, like 100%. It's the maximum, but this one was way over.
Okay, I'll take a look at that. It has to do with how I set up the base point for a particular question, so I might have added up the points incorrectly.
Okay, and then I can just bring my test in and talk to you about the last one to see what I did wrong. Right?
Okay. Or you can just send me an email because I have a scanned version of that,
Okay.
so I can just
That
mark
works
it up and send it back to you.
Thank you.
I sent you an email again the other day about checking the assignment statements.
Assignment statements.
That was one of the first assignments. Remember my?
I haven't graded yet, so so that's good. It's good to remind me.
Okay.
Yep. Yep.
You haven't graded the assignment statements yet?
No, because I. Which
I
one?
emailed mine into you.
Okay, I remember that. Your
That was a
last
long
name
time
starts
ago.
with a T.
Yeah.
Yep.
My user, the ID was wrong. So I
Right.
couldn't get the user.
Yeah, yours was a transpose. I transposed 2 digits.
Yeah.
Yep. So I still remember that.
I had the
All
same
right.
problem. I even printed it out for you just so you could see it. So I had the problem with it. And then you also emailed me that you needed my, so you can see there's no eraser marks.
Okay. Okay.
Oh, actually, that's on this one. But I wanted to explain something about this. When I read the question, I kind of misunderstood the question. And I did do all the operations correct on mine. Mine happened to be all forgets. And I understood what I was doing. I knew exactly. I just wanted to explain to you that I really misunderstood the question. That I was just tracing it backwards, and I didn't put like the left hand side versus the right hand side, even though I clearly knew.
Understood.
And then I didn't trace it when I did.
You're not supposed to trace it. You're supposed to use those rules to derive it.
I only did it in one direction though. I did it from the back, and then I tried to give the.
Okay. Let me take a look at it. If you explain well enough here, I can still give you partial credit for the work of this part. But the question is really asking for the forward derivation. So I have to. You can potentially get partial credit, but probably not full credit for this one. Yep. So yours is missing. It's not missing. It's just interesting how I got your first page, and I got this part because I remember I saw your pictures, but I didn't. The scanner did not pick up the in between. So I'm wondering. Okay. I'll look it up.
Okay, and you don't need this.
I do not need that.
Okay, because there was a problem with mine. The name problem that guy had. I fixed it finally on
Name problem.
On Office Libre.
Oh, your LibreOffice?
Yeah, I'm sorry. Yeah,
That's okay.
LibreOffice.